Hello everyone. So our today's new topic is about ordering the real numbers. And how are we going to order them? We are going to order them either from least to greatest or from greatest to the least on a number line. And before ordering the numbers, we need to make some changes. Now let us start the lesson. Let's revise about what are rational and irrational numbers. Numbers can be classified as rational numbers. Rational numbers are numbers that in decimal form are either terminating or repeating decimals. What are terminating decimals? A terminating number is a number that terminates, which means ends. Example, 3.14, 4 point this number, it is all ended. We don't have, even after repeating, we are ending at the end. So this is called the terminating decimal. But the examples of numbers that do not terminate or do not end are these. For example, this number, it keeps on repeating. Then we have a pi. Then we have another number, but it's not repeating in the same pattern or in the same form. Then we have repeating numbers. A repeating number is a number that does not terminate and it does not end, but it repeats over and over exactly the same way, means in the same pattern. For example, you can see here the pattern as 3.33333 and so on. The pattern over here is 4.34343434. So it is in the same pattern, it's repeating in the same way. But we have some examples of non-repeating numbers that though they are repeating but not in the same way. For example, here 3.34345346, it's not repeating in the same way. So these numbers comes in the irrational group. Now let us versus rational and irrational. If a number repeats exactly in the same pattern or terminates, then it is a rational number. But if a real number is not a rational number, then it is an irrational. Now there are some group of numbers. You need to tell me whether it's a rational or irrational. First number is a mixed number which has a whole number and a fraction. So it is a rational number. Then we have a pi, which is an irrational number because we does not know the value of the pi yet. Then root of 2. Do we have the root of 2? So it's an irrational number because it is not a perfect square. Then this one, 6.25336678. It's ending. So it's a terminating decimal, or we can call a rational number. Now we have to arrange these numbers from least to greatest on a number line. Now what are the rules and what are the steps that we are going to follow? First step is change each and every number into decimals. So this is the first and the prior rule that we have to follow. What is the rule? Change whatever set of number we have, we need to change it into decimals. Then place the number on the line. Now let us start. First make the number line. We have a number line with the negative and the positive integers. Now let us change negative 7 into a decimal. Negative 7 can be written as negative 7.0, which has changed into a decimal. 14/3, it's a fraction. Change it into decimal, which is 14 divided by 3, you get 4.7. It's a terminating decimal. Then 280% will be 280 divided by 100, which will be 2.8. Again we got a decimal. Then it's a mixed number, 1 3/7. So 1 plus 3/7, change it into decimal, we get 1.43. So we have solved the first step as changing all the numbers into decimal. Now let us place them on the number line. Negative 7 is the smallest integer that will come on the number line. So the least is negative 7. Then we have 3 over 7, which is 1.43. It will be in between 0 to 1. Then we have 280%, which is 2.8. Then 14 over 3 is 4.7. So this is how we have arranged from least to greatest. So it's negative 7, then 1 3 over 7, then 280%, then 14 over 3. So this is how we are going to solve the numbers on the number line. Now let us do the second example. We have to again arrange them from least to greatest. The numbers are 5 over 6, 4 1 over 4, 300%, 0.23, and 3 over 10. So let us change them. 5 over 6 will divide it, we get 0.833. 4 1 over 4 is 4.25. 300% is 3.0. 0.23 is already in a decimal form, so we'll write it as it is. 3 over 10 will change it to 0.3. Now come on, arrange them from least to greatest. So we have to check the numbers and arrange them. Then we have to arrange it on the number line as well. So this is how we are going to arrange. Since all the numbers are positive, so we will just put the positive integer line. Now we have to name the sets of the number. What are the names of the sets? So root 6 belongs to which set of numbers? Since we know that square root of 6 is not a perfect square, so it will lie between 2 and 3. So it is not a whole number. So it is an irrational number. Though it's a real number, but it will be in the irrational group. Then root of 100, we know that square root of 100 is 10. That is, it's a perfect square. So it can be natural, whole, integer, rational, and real number. So the name for this number can be a natural number because it starts from 1 to 100. Whole number because it includes 0 as well. Integer because it can be either positive or negative 10. Rational because it is a perfect square, and it's a real number. Now your turn to name the sets of each number. 3 over 5, it's a fraction, so first change it. It's a rational and real number. Negative 2.52, and it's repeating, so it's again a rational and real number. Root of 5, we know that the square root of 5, it's not a perfect square, so it is irrational and real. Then we have root of 121. So square root of 121 is 11. So it's a perfect square. So it can be a rational, real, natural, whole, or integer. Again, 5 over 12, it's a rational number. Square root of 144 is 12. So again, it's a rational number or natural, whole, integer, and real number. Square root of 56. We know that 56 is not a perfect square, so it's an irrational number. Negative 36 over 4 is negative 9, which is an integer, a rational, and a real number. Now we are going to do the completeness property. Each point on the number line corresponds to exactly one real number. For example, we are going to graph these numbers on the number line. Now we know that negative 4, negative 2, 0, and 4 are all the rational numbers. We need to find 4 over 2 and root of 48. Now 5 over 2 will be, if we divide 5 with 2, it's 0.5, and root of 48, we know it's not a perfect square. So let us graph negative 4, negative 2, 0. 5 over 2 is 2.5. Then 4 is 4. And root of 48, square root, it's not a proper value given, but it can be between 6.9. So let's change it into 6.92. We'll just take the second two digits after the decimal and round it. So it will be 6.93, or it can be between 6 and 7. So this is how we are going to find it. Now we need to compare as well between the numbers. Compare between 14 and root of 196. We know that the square root of 196 is 14. So first we need to solve the square root. Then both the sides are 14, so it will be an equal sign. Similarly, square root of 48 and 6.99999, because 9 is repeated. So let us find the square root of 48. It's 6.928, okay, or we'll round it up, it will be 6.93. So 6.9 or 6.9 with the line on the head is repetition of 9. So let us compare now. So root of 48 is 6.92 and 6.9 is 6.9999. So let us compare. So 6.9999, which is repeated, is greater. Now we have given the number line. We have to rearrange them from least to greatest. Square root of 4 is 2. 0.4 is already in the decimal. Negative 2.3 is negative 0.67. Root of square root of 2 is 1.41 approximately. It's not the perfect or the proper given value. Then minus negative 1.5 is negative. It's already in the decimal. Now arrange them on the number line. We have first as negative numbers are the smallest. So negative 1.5, then we have negative 0.67, then 0.4, then 1.41, and then 2. And then we are going to arrange them on the number line. Now let us compare square root of 2 plus 4 and 2 plus square root of 4. We know that the perfect square root of 2 is not the perfect square. So square root comes in between square root of 1 and square root of 4. So the square root of 2 will be in between 1 and 2. So let us take square root of 2 with 1 and find the answer. If we take 1 plus 4 is 5. Why are we putting here 1? Because we are just taking the approximate value of square root of 2. They are 1 and 2. So let us take 1 plus 4 will give you 5. Now let us take the value of square root 2 as 2. 2 plus 4 is 6. Now come to the next. We know that the square root of 4 is 2. So 2 plus 2 is 4. Now which side seems to be bigger? On the left we have two values 5 and 6, which is greater than the value on the left side. So root of 2 plus 4 is greater. Because we are taking the approximate values of square root will be in between 1 and 2. So we have to take one number, put it in place of square root and find the answer. Let's do the second one. We know that the square root of 12 is not a perfect square. So let us find square root of 12 will be in between square root of 9 and 16, which is 3 and 4. So we'll use the values for square root of 12 as 3 and 4. Come on, replace it or substitute it here. First we'll use it with 3. 3 plus 6 will be 9. Then we'll use 4. 4 plus 6 is 10. Come to the next side. 12 plus square root of 6. Again we know that square root of 6 is not a perfect square and it will be in between 1 and 4. So let us find it. Square root of 1 will be 1 and square root of 4 is 2. So let us substitute square root of 6 with 1 and 2. So we get 13 and 14. So which side is greater? Of course the left side. Now again we have given here the numbers, we need to arrange them on the line. So first find the square root of 2, then pi plus 1, then 4, 1 over 2. So let us first change them all. We'll change them all into the decimal and then arrange it. So from least to greatest we get pi plus 1. What is the value of pi? 3.14. Plus 1 will be 4.14. So it will be in between 4 and 4.2. Then 4 and half will be 4.5. And then the square root of 22 will be in between square root of 16 and square root of 25. So it will be between 4 and 5. So it will be in between 4 and 5. So let us take 4.7 approximately. Then we have the next root of 5, 2.5 and root of 3. So let us first find it out. We know that root of 5 is in between square root of 1 and square root of 4. So it will be in between 1 and 2. Then square root of 3, again it's in between 1 and 4. So square root of 3 will be also in between 1 and 2. Now let us, now since we got the square root of 5 and 3 in between 1 and 2, which square root will be least? Root of 5 or root of 3? Root of 3 will be the least, then root of 5, and then we know 2.5. So arrange them on the number line. Root of 3, it's in between 1 and 2. So let us take as 1.6. Root of 5 will be in between 2 and 2.5. And square root, and then 2.5 will be here. So this is how we are going to arrange them. Then let us find the next pi square. We know the value of pi is 3.14 and it says square. So let us square it. We get the answer 9.87. Then we have 10 and then we need to find the square root of 75. We know that 75 will be in between 64 and 81, which is square root of 75 will be in between 8 and 9. So let us put the values from least to greatest. We know that the square of pi is 9.87 and 75 is in between 8 and 9, so it will be less. So first will be root of 75, then pi square, and then 10. So let us arrange them all on the number line. Root of 75 will be in between 8 and 9. Then we have pi square, which is in between 9.5 to 10, because its value is 9.87. And then comes the 10. Now the same way we are going to do. Find the value of root 28. It's in between 25 and 36, which is 5 and 6. So let us take, multiply from 5.1 to 5.1. We'll get 26.01. No, let us multiply 5.2 and 5.2. It's again getting 27.05. If we multiply 5.3 and 5.3, then we get the approximately as 28.09. So we are going to use the value 5.3. Then change this one into decimal. Then 5.5 will take approximate value or round it to 5.6. And 5 and half will be 5.5. Now let us arrange them on the number line. So we know that the values first will be 5.3, then 5.5, then 5.6 and 5.75. So in this way we are going to arrange them on the number line. This is the example in your book. I would want all of you to go through it. And the last question is a homework for you. I want you all to solve it by yourself and show me in the class. Thank you.